Okay, the line 3x plus b is a tangent to the curve of this, right? So this is the function, fx is that. Find the points of tangency and the b for each point. Is it find the points of tangency? The tangent, so first thing first here, we know the tangent line is what?
Derivative.
The tangent line is y equals what? Zoe? Y equals what? The tangent line. Good. 3x. No, 3x plus b. That's the tangent line. And this, the function here, is the curve, right? Zoe? For Anna, what's the function? Function just like this one, any curve, that's this one, right? And then they said there is a tangent line, which is tangent to the curve, like this, And then, so this is a tangent line, and this is the graph, like this. See that? This is the function here. This is tangent line, okay? Find the points of tangent C. Means they ask you find what's this point here, right? So how do you do that? Find derivative. Okay, Amanda know that? Okay, so we find the derivative. So suppose this is fx, okay? So we try to find the derivative. F derivative equals what? Read to me, please. Derivative. X what comes?
To the 4.
Fourth plus, oh no, minus.
Minus.
So minus, right? Minus
3x cubed.
3x cubed. And then
Plus.
minus
Plus.
Huh?
Plus.
What plus? This is minus.
Oh,
no. This is what?
17x.
17x squared. And the plus 39x and minus 17. No problem? Okay, now they want this one equals what? Because we know this, we're looking for this one, x and y right now. But at this point, x going at this point, the function, or we can put this one easier for you. So we put at this one as hold on, not, we can put as x1, y1, okay, like this. So let me ask you, what's x1 right now? Oh no, we're looking for x1, y1 right now. They ask you find the point of tangency. And if the derivative at x1 there, what's the derivative should be equals to? Zero. Sorry? Okay, here. This line is y equals to 3x plus b, right? So what's the slope for this line?
3.
3, good. The slope here equals to 3. And then what's the slope of tangent line? No, what's the this derivative representing what? The slope of the tangent line, right? Derivative at that point, function derivative at that point represent the slope of the tangent line at that point. So this one should be equals what?
3.
Great, equals 3. So if we know this one equals 3, we can get what? We can get x4 4th minus 3x cubed minus 17x squared and plus 39x and minus 17 equals what? 3, right? Hold on. Let me just send this bad boy. This one just what? We need to solve this equation now. So first step will be this. Minus 3, minus 3. Can you follow me so far? So we got what? X 4th minus 3x cubed minus 17x squared plus 39x minus 20, right? Equals to 0. No problem? Now, when you have this, right? And then, when you have this, how do you solve it? This one looks like it's hard for us to do, like the fraction, right? So we can get the calculator out. Everybody get a calculator out, and we're gonna work together. You have a calculator? No, double ring. Yeah, I just let you borrow this one. Yeah, yeah, let borrow. Yeah. So, so what we're gonna do is first thing first. We gotta get a lot of intensive training about how to use the graphing calculator. Okay. We go to y equal. See that? Right? Y equal. Huh? So when we have a y equal, we got a what? X. How do you know how to key in all the data? Can you please key now? So we're gonna have x to the 4th power minus 3x minus 17x squared and a plus 39x minus 20. Can you follow me so far? Hold on, I keyed something wrong. Okay. So x to the 3rd of 4th. Have to be on the. Okay. This is not. Oh no, no. Oh no, I just pause it here. So you go second function. They have a calc 1, 2, 3, 4. The 4th one on the side. Can you see that? The 4th one, you got a calc. And then you scroll down to the 2, the zeros. Means zeros means the solution. Okay? So we go this one here. So you will see the graph for you right now here. See that? Okay. First thing first. This equation, this polynomial equation, the highest power is the 4th power. They're supposed to have how many roots? How many zeros? 4, right? Get it? This is at 4. So what we can do is this here. We can find this 4. Be careful here. When you see that here, this one, there was one intersection. You see the graph there? And on the right side, on the left side and the right side, they have one intersection there. But at the bottom, in the middle one, they have what looks like a parabola touch on the x-axis. Remember, when it's a touch, that should be what? Either double roots or 4th root multiplicity of 4 or 6 even numbers. If it's a cross here, if you cross, means what? They have either 1 root or multiplicity of the roots of what? 3, 5, that's odd numbers, okay? So, but of course, right now we can assume that on the left side represent 1 root, right side another one, okay? multiplicity is 1 for each. Not, do you know what I'm talking about? Multiplicity of the roots? What's that? Oh, no?
I don't know.
Oh my gosh. Yeah. For example, you have x minus 2, third power equals 0. What's x? What's
2.
x? 2, good. But how many times you got 2? This is x minus 2 times by x minus 2 times by x minus 2 equals 0. So you have 3 times you got x equals 0. So that's what we call the multiplicity of the zeros is what? 3. Okay? If it's odd, we knew that should be just cross the x-axis. But if it's touch, like this one is touch, probably like this. X minus 1 squared equals 0. How many times x equals 0, x equals 1? 2 times. Clear, Zoe? Okay. So now let's see what's the value for that, okay? So you go like this. You go second function calc and then scroll down to the zeros. You will see they have a left bound there, right? So we try to move the cursor, to the negative 1 first, okay? So negative, oops, hold on, where's the graph? The cursor is negative 5 already. Let me see the window. Window is like this, okay? So you go this one, calc, and then you put the 0 there, and then you will see this graph should be 1, 2, 3, should be negative 4, looks like, huh? Right? But I couldn't see the cursor. What's wrong? Oh no. We change the window a little bit more first. We change to the negative, the y coordinate, okay? Y coordinate for the negative 50 to positive 50, like this. Okay, and then we're going to calculate in the zeros, and then we see what the graph looks like. Okay, so, okay, we try to go by, because now you can see the cursor now. See that? I changed the window here. Everybody look at here. I changed the window to x is negative 10, positive 10. But y minimum is negative 50 and maximum is 50. By that way, because before the cursor is lowered down there, cannot see. So right now, after you do that, continue go second function, calculate, and then go to 0 here, okay? And then you can see cursor now here. Okay, we try to find, have you got this now, everybody? So you may see it closer, can see? Okay, so when you got this one, they ask you for the left bound, right? So when you go left bound, you move the cursor, use this one here, use the right arrow, move it to as close as possible of the touching point of the x-axis, but on the left side, okay? So you enter, and then go to right, and then they say right bound. Enter, and then equal. They'll give you the number. Okay, what do you got now? What's the first root? No, I got the curve one. I got this one first. Here. What do you got? What do you got? Oh my God. Hold on, I just pressed the curve. So from here, we can see that x, you got 4 roots. We use the graphing calculator. We'll find out x equals 1 and negative 4 and 5. And the x equals 1 twice because the graph touch on the x-axis. Understand that? Okay. Now, let's go back to this question here. They said this one here, find the points of tangency. Find the points of tangency here. We find it. Oh, not done yet. Huh? We find the x, we're gonna find the y, right? What's the y? What's the y without calculation?
0.
0? How do you got 0? X equals 1, huh? Of course, if the x equals 1, plug into here, what's that? 0, right? But that's derivative, huh? That's derivative. We know f derivative of 1 equals 0. F derivative of what? -3, -4 equals 0. F derivative of 5 equals 0. No problem with that. But we're looking for what? F1, F -4, and F what? 5. That's the corresponding y coordinate of this kind of point. You understand? The graph probably like this. They go like this one here, touch one more time, tangent again, and then tangent again, probably like that. Nah? We don't know. This is the general sketch just for the illustrated purpose. Not big deal. But they just say we have that many. This one tangent line will hit at different places, probably like that. Or, no, not like this here. The story is this here. Hold on.
Do you have tissues?
Tissues, hold on. So this question number 1, they ask you find the points of the tangency and the B for each point, right? What we're gonna do is this here. First, find the point of tangency first. Point tangency, we go F derivative of F1 actually. So we can use the calculator one time, get the deal done, okay? Now, you continue go to y squared, follow me please. And then you clear the original record, you key in the function now. You key in this function as y equals like this, huh? So you key in, what, 1/5. So you can go 1/5 times by x to the 5th power, right?
Yeah, I can put it in parentheses.
Yeah, put parentheses the better way. The reason for that times afraid of like what's it called, computer may be like confused. Put parentheses is the better way, but this one I think smart enough, they can recognize that. So to the 5th and the minus parenthesis 3/4 and the 5th, and then, or you can put like this one here. You can put at minus 3/4, you can put at 0.75, also good. And the x to the 4th power, right? And then you go minus parenthesis 17/3, closing x to the 3rd power, and then plus 39/2, right? And x squared and a minus 17x, like this. So when we have that, let me show you how. You still go by zeros. You go second function. Oh no, you don't need that. You don't need that. You find the value of the 1 and like, you go table set. You know where's the table set? Second function table set, okay? And then you're interested with what? F1, right? So you are interested in F1 equals what? You just go by here. You go table set as a start at the 1. Here, like this one. Table set is 1. And then increment by put at 1, doesn't matter. We just need one value there. And then you go second function table. Second function table here. Yeah. You can see what's the first value? F1 equals what? Negative 3.7. See that? What do you got?
The table start.
So you have this one, f1 equals to negative 3.7. How about you need to find f negative 4? You go like this one here. You can screw it up. Negative 4. Because what? 345 or 346. Have you got that? Eh? Let me see. F, we have f negative 4 equals what? Amanda?
345.
Okay, and then you have F5, right? So you already got F5. Negative. F5 is negative 149.6. Have you got that? Amanda? Anna? Sorry? Okay. This question, they ask you for what? Find the points of tangency. So the points, you can put it together like this one is what? 1 and what? Negative 3.7, right? And then negative 4 and 3, about 346, like that. And then the other one is what? 5 and what? Negative 149. Oh, 949.6 around that. Okay, listen, the method is important here. You got it? You may round up because they're not saying round up to where. I think anyone is okay. Now, but they ask for what? For the B. How do you find the B? How do you find the B? Amanda.
You plug in the.
Right, you plug in, huh? You plug in, yes, good, good. So we're gonna plug in here. I'm going to plug in the 1 to here, to this equation, okay? So, oh, no, plug into this one now, right? For example, here is what? 1 and negative 3.7 at this point. This is one line, huh? So you have what? Negative 3.7 for the y equals 3 times 1 plus b. Can you follow me? Right? And then you will get what? The b equals what? Negative 6.7. Huh? And then you can determine the tangent line now equals 3x minus 6.7. That's one way. Get it? Any questions so far? Now, you may have another one here. Let me show you the graphing here. Yeah, because this one, the slope must be what? Always 3, but the b keeps changing. So probably like this here. Yeah, look at my graph here. Probably like this. You have another b. How do you find another b at this point? Because suppose this one is what? 5, okay? X is 5. And they can find a y is what? Negative 149.6, like this, huh? And how do you find the b? Zoe, how do you find the b for this point? Huh? Y equals what? Negative 149.6. 3 times what? What's the x? 5, and then plus the b. So you can find the b, right? Similar, you can find the when x equals 4, negative 4, y equals that one, plug it into the equation of the tangent. So you can get those, right? No problem? Okay. Is that clear? So this one, they just say, let's recall what we have. What? We have a slope, we have a tangent line like this. We have the function like this. This tangent line to this function. And then they ask you at where the point of tangency there. Means you need to find the x coordinate. How do you find the x coordinate? Make the derivative first, right? After you got the derivative, and then you make this one equals what? 3, because the tangent line always the slope is 3. From there, you can solve the different x. And today I showed you how to use graphing calculator, use the y equals 2 and find the zeros, and you can find it, right? So this saves time. Actually, this is very powerful because I use this one for this algebra 2, the calculus algebra 2, and also statistics before I was using that one. It's very powerful. Just with this one, you bring this one anytime, very fast, especially for the statistics, like a normal distribution. You do not need to always bring the book with the chart to follow, to find the tables. And I use this one very fast to get it and accurate. Now, we go to the, so far so good for number 1. Okay, we go to number 2 now. Find the tangent line, find the lines tangent and normal to the graph of this. Normal, tangent and normal. Okay, let's do this now. Curve. I just generally sketch here. This is the curve, like this one, right? Whatever. I don't care what's whatever. But they asked for tangent. We knew how to do tangent. Huh? Find the tangent line at this point. So this means this time we have what? We know the point here. We already know the point here, which is 4√3 and then -2. No problem? Now, find the lines of tangent to this one. We need to determine the line now, right? Okay, tell me, what's the first step? Armando?
Find the derivative.
Because we're looking for tangent line equals what? Slope times x plus b, right? Got it? We're assuming like that. So we need to find what? The slope, right? How do you find the slope? We have to find the dy dx. Is that clear? Zoe? Okay. Now, everyone get a sheet of paper, do this now. We have the function here, this one, right? Now, when we do this one, what do you got? Derivative, it will be what? 2x. And the dx is 1, never mind, no problem. Okay. This part now, what do you got? Zoe. That's 32, right? And then? Y, and then? But we're looking for dx. So this is a 32y, and then don't forget you have dy dx here. Armando, understand? Because we're doing chain rule. Keep in your mind, we're doing implicit differentiation for this equation. And our derivative not just ends at the y, it ends at what? X. So you use the power root to derivative of y squared. You got 2y, that's good. So times by 16 is 32. But don't forget, you have to do derivative of dy dx. And then we continue. 96 here, right? And what's this one should be what? Anna.
96.
And then? Armando, agree?
Yes.
Okay, because we do d to the x, right? Because y is the function of x. Okay, d80 equals what? 0, right? Constant 0. And the zero derivative is still zero. No problem. So far, so good? Okay. Now, because we're looking at this tangent line, we try to find the slope of this one here. So this one here. So they told you the point already, right? So to make it easier, we can do the substitution right now instead of working on so many times with the letters, okay? So here, x equals what? Huh? Because we are interested in dy dx, 1x equals what? 4 root 3, y equals what? -2. That's what we're looking for. We don't care about the other points right now on the graph. Is that clear? Okay. If you knew that, what happens? So you have what? You have 2 times by what? What's x? 4 square root 3, right? Plus 32 times by what? What's y? -2, right? And then we look at dy dx, no problem. And then we add by 96 dy dx. Can you follow me? And then equals what? 0, right? Now, what's our job right now? We're looking for what? Dy dx, right? How do you solve this one? We got to move this one away to the right side, right? So this is basic algebra. Huh? So I'll keep this part first. So this one is -64 dy dx plus 96 dy dx equals to -2 or -8. You time together, okay? Try to make it simpler, the better. So you have what? -8 root 3. Can you follow me? Now what's the next step? How do you combine them? What do you got? Amanda, what's this? Uh-huh.
Why is it -8?
Because I move on this side onto the right side right now, right? Is that clear? Okay, go get more tissues at one time. So you just simply use what? 96 minus 64, right? You got 32. You got 32 of the dy dx equals 8 times by root 3 negative. No problem, right? And then you can find dy dx equals the divided, so -8 root 3 over 32. Huh? So we can get what? -3 over 4. Right? So we find the slope. So I can put it here, okay? So by that way, you see here, Amanda here, we just simplify this two, get this one, and then find dy dx equal to this one, okay? Right? We just solve this differential equation. We find dy dx. When we got dy dx here, we know this slope equals what? -√3 over 4. Huh? X and the plus b equals y. No problem?
Wait, that's tangent.
Yeah. We are, okay, be careful here. We have a dy dx at 1x equals what? 4 root 3. Y equals what? -2. What does that mean? Means we're looking for the tangent. We were looking for derivative at this point. When was the derivative at this point? Dy dx, that's represent the slope of tangent line. So that's why if we say this is a tangent line, y equals x, so I have this one. Zoe, any questions so far? No question. Armando?
No.
Okay. And then, did we find the slope of tangent? Oh, did we find the equation of tangent line now? Yes or no? Zoe? Amanda? Yes?
No.
Why no?
It's the B.
We don't know the B yet. You're right. How do you find the B? Anna?
You plug in X and Y.
Okay, X equals what?
4 square root 3.
4 root 3, right? Because that's the point. Because this time the tangent line touch on the graph of the function, so share the same point there. And as Zoe, what's the Y should it be? Good. Okay, solve this question right now, please, everybody. We're practicing this one also at the same time practicing algebra skills and practice about differentiations. Okay, it's the overall practice. So right now we have -2, -√3 over 4x. Oh no, x is, we knew the x already, huh? X is, we knew x equals time by 4 root 3 and a plus b now. So the 4 cancel. -2 x plus b. Do you get the same answer as what I got? Okay, now here. We're looking, we finished the tangent line right now, right? This is tangent line. And then we're looking for a normal line. Still passing the same point, huh? So they have here, this is normal line, perpendicular to this. We already know this is a tangent. Already, yeah? Normal line now. How do you find normal line? Normal line is a line, right? So we still have y equals what? Mx plus b, right? But different m, different b. Zoe, can you tell me what is the slope right now for the normal line? Do you know the slope of this tangent line now? We knew that, right? What's that? -√3 over 4, right? So, Anna, if you know this line, tangent line slope is -3 over 4, √3 over 4, can you find this the slope of the normal line now?
Is it the reciprocal?
Reciprocal equals what? 4 over √3. But it's not only reciprocal. It's called what? Opposite. So you should have a negative here. Oh no, positive here. Understand that? Okay? As long as you know the slope of one line, you can find the slope of the perpendicular line to that line. Just simply reciprocal and change sign. That's algebra. Okay? Right? No problem? So right now we find y equals to 4 over √3x plus b. Can you follow me? Right? And then how do you find the b? Armando.
You substitute the X and Y.
What's x now?
4 square root 3.
4 √3. Because The normal line also passing through the point of tangency. Huh? So, and then this y equals what? -2, right? Sometimes by 4/√3 and plus b, yeah? We cancel, right? So -2 equals 16 plus b equals to -18. So finally, we find the y equals 4/√3 x plus, minus.
Can you cancel over?
Of course, we're going to do that. Yes, very good. I know it's good. So you are like, what, alert that, right? This is not in simplest form yet. Huh? So Armando, how can we simplify this one? 4/√3.
Multiply by square root 3.
Zoe, do you agree with Armando? Okay, good. So time by √3 for both numerator and denominator. Okay, finally y equals what? 4√3/3 minus 18 x here. So this is a line. We find the normal line now. Any questions so far? Right. You need like do it by hand like this, hands on. Like Miss Lee, what I'm doing right now. And I just, do one by one without mistakes. And at the same time, explain to the students. You understand that? This is the first time I'm doing this one. And I just do it correctly. That's called what? Ability. When you take the test, it's the same, man. They gave you the test there. They gave you the questions there. The first time you saw that kind of question, you just go ahead and do it. Based on what? Based on all solid foundation of your knowledge. For the tangent line, slope should be derivative of, right? And also you knew that who's in?
Oh no, my Wi-Fi.
Oh, okay. And also you knew that. And also you knew that there's like what? A normal line, the slope should be reciprocal opposite sign of those. So you have this equation, right? And also you're good at what? Doing the differential equation for this kind of function. Do the differential equation of this kind of function here, huh? Without any mistakes. And do it with the speed and accuracy. That's the AP exam looking for, okay? Understand is the first important step, but that's not the only step. You have to be understand, based on your understanding, do it fast. And without mistake, without the errors. That's what I'm looking for. How? Ms. Lee can help you understand. Show you the strategies, shortcuts, make sure you understand all the ideas. That's no problem. But you are the one who got to practice. I always tell my students, Miss Lee is a coach. Do you play basketball? I play basketball. You know play basketball? Okay, I'm very good at playing basketball. I always use this one as an example. I say, hey, Miss Lee is a coach, show you how to play basketball, how to shoot. But you got to shoot what? 100 times and then make it perfect. Is that clear? Okay? Not just based on, oh, I understand Miss Lee said. It's good. I feel good. I understand. No good yet. Because when I ask you, you do this question by yourself, you got stuck somewhere in between. You couldn't get a good performance on the AP exam. Got it? All right. Now, based on what I said, we do the, oops, hold on, what's wrong? This one not. So let's look at number 3. How many tangent lines of the curve this one pass through this one? You do it by yourself now. So right now, it is your turn to do this now here. So I should make sure I'm recording this one. Okay, here. So you said find derivative. So what's the derivative right now? Of x squared plus 12, right? No problem? Okay. Now, they told you what? How many tangent lines to the curve passing through this point? So, you find slope first, right? Because we know the line should be y equals mx plus b, right? What's x equals 1? This time x must be equals what? X coordinate?
1.
1, right? Because here they told you the graph is like this. This point is 1 and 1, right? The tangent lines go this way, like this, huh? So x equals 1. So you need to find slope. Derivative dy dx 1x equals 1. So equals what? Equals to 24, right? Got it? And then they ask you how many, no? So what are you gonna do? What's the next step?
How did you get 24?
Because I plug in x equals 1. Because I'm only interested with the point at the 1, 1 there. So it's 12 times by 1 squared plus 12 equals 24, right? Get it? Okay, right now, let me ask you. So you have y equals 24x plus b. They ask you how many tangent lines to the curve of this one passing through this point. Oh, wait a minute. This one a little bit different. Hold on. This is the, huh?
Not 1.
Is that a 1?
No.
No, right? Do you see that? So this question a little bit different with what? The previous question. You understand that? You see? When x equals 1, this is 4, this is 12, and minus 5 cannot be 1. Got it? So we have to use a different way to this one. Let me show you here. The story is this. We have a graph like this. And suppose this is the point 1 and 1, like this, okay? They ask you how many tangent lines passing through, like this one here. At least you have 2 there, right? Passing through this point and a tangent to this and this. You understand that? That's this question about, okay? So if that's the question, what are you gonna do? Suppose we have this one is what? X1, Y1, X2, Y2, like this, eh? So what are you gonna do? We do this one. We still do the derivative first, eh? dy dx equals what? Equals 12x squared plus 12. Understand that? No problem, eh? And then you're gonna have this is how many tangent lines? Okay. I just use, okay, we just not x1, y1. We just say xy, okay? So this is x, this is y, like this, huh? And xy may be here, xy may be here, okay? We don't know, right? So if we say how many, that means you will find how many pairs of x and y, like that. So what I'm gonna do is this. The tangent line, this is slope. This one equals the slope of this tangent line, huh? And also we have what? Y minus 1 over x minus 1. I'm using so because the point, any point of tangency, we put as x and y like this. So if it is here, you can use this point and this point to find the slope. Y2 minus y1 over x2 minus x1. Can you follow me so far? That's the slope. Equals what? slope of this, right? This is slope, right? So equals what? 12x cubed plus 12. Can you follow me? You understand? Okay, one more time, huh? This is the function. If you want to find the slope of the tangent line to this function, you need to do dy dx, no problem. And then we got this one. We know this is slope, but this slope depends on where the point of tangency, which is x and y. We don't know exactly where the x and y yet, but we just put it there first. So we know if the lines like this, passing through the xy here, the tangent line slope will be like this. No problem so far, Zoe, Anna? Okay, if you think this is no problem with the slope, and there's another way to represent the slope, the same slope. 2 points here right now, see that? You see 2 points here? Here and here. So these 2 points, we can find the slope again. Y minus y1 over x minus x1. You got it? That's the way when we do the middle school math, we find slope y2 minus y1, right? Remember that? Because this one and this one, they're representing the same slope at the same point to the same function. So they must be equal. Is that okay with you? So we can get a what? We time both sides, okay? Time by both sides by x minus 1. We got a y minus 1 equals what? X minus 1 times by 12, x cubed plus 12. Answer that. Sure?
What does y1 over x1 stand for?
Slope, huh? For example, you have a line like this one here. For example, this is a 3 and a 5. This is a 2 and a 4. How do you find slope? 5 minus 4 over 3 minus 2, right? Like that. y2 minus y1, x minus x1, huh?
Oh, y2 minus
y2 minus y1. Okay, the formula for the slope is what? If you knew the 2 points, slope equals y2 minus y1 over x2 minus x1, huh? Right? So we knew this point, which is the x and y. We knew this point, which is 1, 1. So I assume this is x2, y2, this is x1, y1. This is y2 minus y1 over x2 minus x1. That's why we got this one as a slope. Okay. After we got this function, we simply go like this. We go y equals what? X minus 1 times by 12x cubed plus 12 added by 1, right? And then what we're going to do is what? We just key in this one to the function, okay? To see, hold on. When we got this one, so they are not asking what's the points there. It's just how many tangent line. Eh? If you want to find how many tangent line, we got this one here, and x equals 1, 1, 1 is 0. So that means we gotta go by this x, y, they're like not. So we just key in this function right now, okay? So we can get here